we're gonna explain the ones that I did mention a lot, ANOVA 1. So what's ANOVA 1? What's it's abbreviated from? It's just one-way analysis of variance. What's the difference between ANOVA 1 and ANOVA without 1? So ANOVA 1 is just one-way analysis of variance, as I said. ANOVA without the 1 means one or more ways of analysis of variance. So again, as always, why we do care about ANOVA? So this time it does compare multiple group means, simplifies statistical testing like F, CDF, F, INV. All these functions that we did explain before, they are completely relevant to ANOVA. Also, it has it can visual data and interpretation and has a lot of application in real world studies as engineering, economics. So ANOVA used also for arguments, when people do want to argue about whether all population mean are equal or not. Maybe arguing about the alternative and null hypothesis. So all of this, I can do all of this function just by using ANOVA. So let's see an example. So let's see y equal, start with meshgrid 1 to 5. So meshgrid is basically we are using this function just for making the dimension constant about two variables, but right now it just as brief explanation for meshgrid, it makes the length of y will be the number of rows and the length of x will be the number of columns. And right now, because it ends with 5, so I'm gonna expect the meshgrid to give me 5 multiplied by 5 matrix, which means 5 rows with 5 columns, all has the same dimensions. But right now, gonna give me one variable because I specify just the y, not two variables. And right now, I'll make RNG, which is random number generator, and I will press this as default. So this for just reproducibility, and now we have to expect using rand functions. So random number generator default, it's always relevant with rand function, which is random number. So we're gonna use it in a different way. So let's create y1. y1 will pu. Right now we're gonna use the normrnd, normal random number, and now 0, 1, 5, 5. What this means, what each position mean. So 0 means it's my mean parameter, 1, my standard deviation, 5 and 5, these are the sizes that I did the mesh grid about them, which will be 100 mesh grid. And now y1, this is the value, the input variables that I will plug in ANOVA 1 function. And basically the normrnd is the normal random numbers. So that's why when we use this for reproducibility, it always followed or combined with using normrnd after. Okay, so let's see when we making p equal ANOVA 1 right now, y1. Let's see what we can get. Oh, okay, so there is an error in line 52. Yes, so there cannot be suppressing. Let's see what we can get. Okay, so ANOVA give me a table and figure. So let's start explaining the table. So the SS means sum of squares, DF mean degree of freedom, MS mean square error, F is the ratio of mean square error, and P is the probability, and it's comparing to me with F. So why we care? What's the point of this table? No, the point of this table is that you might want the degree of freedom to calculate another function, or maybe having the mean square error to put it in another formula and get another result. So it's all of them are connected. And also we did assume all the degree of freedom, like we assume the degree of freedom 1 equal 8 or 5. But this is not always the case, especially if you have the real world data. You want the degree of freedom to be authentic and real, not just like assuming them. And you can do this by using ANOVA. Same as like sum of squares, same as the probability. So it gives you a lot of elements that is super, super helpful and important when you want to calculate another function.